Hi everyone, this is Hitesh Santwani here, and my teammate is Ditya Sridharan. So, we have taken this Kaggle challenge as our HDM project. First, Ditya will explain the problem and the insights that goes about doing the EDA on the dataset provided on the Kaggle, and then I'll approach the paper published by Google engineers to solve this problem and why they put this problem on the Kaggle.
So, the topic that we have chosen for the final project for the spring semester SDM is unintended bias and toxicity classification. So, this topic's idea basically stemmed from a challenge that was raised by Jigsaw for creating machine learning models that can identify toxicity in online conversation, where your toxicity is defined as anything that is rude, disrespectful, or otherwise likely to make someone leave a discussion. However, as we can see that with this huge proliferation of ML in the various tasks in everyday life, we can see that a lot of these models that are built from very human specific, as in which are built from human specific or human generated data, they tend to get a lot of human bias, and it sometimes results in a very skewed distribution. So the main contribution of this challenge is it basically intends to introduce methods to quantify and mitigate unintended bias in text classification models. So you want to classify the comments to be toxic or non-toxic, uh, and so on. So we also intend on demonstrating how imbalances in your training data can lead to unintended bias in the resulting models, and therefore they can lead to very potentially unfair applications. So we already use a set of common demographic identity terms as a subset of input features on which we measure this bias. So, this technique permits analysis in the common scenario where not just your demographic information, say on your authors or the readers, is unavailable, so that this bias mitigation focuses solely on the content of your text itself. But, however, we will be doing some visualizations or some analysis on your demographic information as well to better understand the data that we have on hand. So this mitigation method that we plan on introducing is an unsupervised approach, which is based on balancing the training dataset. So, in order to understand what exactly this unintended bias is, let us look at a very simple example. If a comment reads, "Say I am a gay man," this is obviously not a toxic comment or is not a threat or something. So but however, this comment which reads "I am a gay man" was given very high, unreasonably high toxicity scores. So this is what we call a false positive. So this is because the particular term "gay" has been used in several contexts in your in your data. So this model that is solely built on your human generated data tends to take this "gay" word as a representation of a toxic comment. So the bias here was the disproportionate representation of identity terms in our training dataset. Say this "gay" word is what I refer to when I say an identity term. So this is because in all your this "gay" comment has frequented several toxic comments in the model, and the model has overgeneralized it and is inappropriately associating these words with the toxicity label. So we intend to do away with this because this is of rising importance today. So we intend to do away with this. Um, this apparently the word "gay" appears in 3% of toxic comments, but only 0.5% of the comments overall. But you, I mean that makes no sense. So we what we intend on doing is to get rid of this unintended bias in our classification. Um, to go about before understanding how to solve this problem, we looked into several previous works, previous papers that talked about this. So most of the works that we looked into, they suggested a strategy to alter the training data itself to improve the fairness. or most of these works relied on the use of demographic data as the object of classification in order to identify and understand and mitigate this bias. But very less of this very little of these prior work has been done on the fairness of the text as such. But we intend to go about this mostly based on just the text for our classification. For that, we need to balance our data, obviously. But however, that is obviously easier said than done. So, before we go about the entire analysis process, let us better understand the data. So, the model task that we have at hand, we have done it with using convolutional neural networks and Kira's framework in TensorFlow. So, what data are we exactly working on? So, at the end of 2017, the Civil Comments platform made their 2 million public comments available in an open archive so that we researchers could better understand and improve civility in online conversations. So, in the data that we were supplied, the text of individual comment is found in a text column. So, you have a column which just represents the entire comment, and each comment in your data, they have a separate toxicity label associated with them. So this toxicity label and the model aims to predict the target toxicity for the test data. So this attribute or this toxicity attribute is basically fractional values that represent the fraction of human raters who believe that this attribute applied to the given comment. Say they believe that this is a toxic comment. So for evaluation purposes, we assume that the test set examples with the target toxicity which is greater than 0.5 will be considered to be a positive class. That is, they will be classified as toxic, whereas the ones which go below 0.5 are classified as non-toxic. So to better understand the data before we move into EDA, let me just tell you about what exactly the data schema gives you. So additionally, other than the comments column, you have a subset of comments that are labeled. You have these are probably the most important columns or features that you have in this data. So you have two different labels. One is the label which suggests the identity attributes. So this represents the identities that are mentioned in the comment. So the columns corresponding to the identity attributes are listed below. Let me just give you an example. Say the identity attributes I'm talking about is male, female, transgender, heterosexual, bisexual, a Muslim or Christian or Jewish, and so on. So this basic or black, white, or something like that. So this basically indicates or stands for uh, a particular ethnicity or color or race or your gender or your sexual orientation or something, anything that signifies your identity. And then we have another label that gives you the toxicity label. So these are, say, if I can label these comments as funny, obscene, threatful, or something that is an act of disagreement, and so on. So you have several labels like that. So in the EDA, we'll get a better look at all the labels. But before I go into the EDA, I just wanted to give an example of how exactly this works. Let me take a comment. If I'm going to say I'm a white woman and people are not too crazy about me either. So if I take this comment, the toxicity label should be 0 because in this context, crazy is not exactly a toxic word. It shouldn't be treated as a toxic word. And your identity mention labels, you have two identity mention labels because you're saying white and you're saying women. So we're going to read this text as such. We're going to categorize them into these different labels and then perform our analysis based on it. So to better understand how to go about to see if we are moving in the right direction, let's do a few visualizations using EDA. So firstly, let's try to understand what exactly a target distribution says. So first things first, I always like to start with an histogram to understand your target distribution. So I just started with with a simple histogram which gives you the target distribution's frequency. In this simple histogram, you can clearly see that most of your comments tend to stand below zero point 0.5, as in the frequency of your comments below zero point 0.5 seems to be higher. So this clearly indicates that your most of the comments tend to be non-toxic. However, we do have a certain percentage of comments, and in under which exact target category do they fall into. So this histogram, we can see that. Now, to have a cleaner version of this, let us do a binary distribution of that. So this here you can see that 92% of your comments tend to be non-toxic, whereas 8% of your comments tend to be toxic. So I want to better understand this toxic comments. So that is what I care about mostly. So let me go into that. So first, if I'm gonna have a scat here, I have a scatter plot. So in this scatter plot, this is basically a scatter plot between the number of toxicity annotators and your comment length. So this is done with different, like, say this is a character level and this is a word level. So if I'm going to take you here, you can see that uh, most of your, as in by toxic annotators, what exactly we mean is these are words that indicate of any toxicity. Like these are the words that indicate or annotate toxicity, and this toxicity annotator count is another important column in our schema, which gives you the number of comments, as in the number of toxicity annotators in each comment. You can see that this when you compare your toxicity annotator count with your comment length, you can see that most of your highly toxic comments are not too big. They're kind of small, and most of your very highly like most of your huge comments, which has a huge length, or which is probably paragraphs, have very low toxicity count. So this is probably because, like, say your comments could just be one single swear word or something like that. Uh, that might not exactly be a toxic threat or a toxic disagreement or something that ruins the conversation, but it does kind of bring down the civility in that discussion. So this is just an open comment on it. It could just be one single swear word or something that is more of an exclamation than exactly directed at, it need not be exactly directed at one particular person in the comment section, but however we still will be considering them to be toxic. So that is how toxic annotator count and comment length is that's how they're related. So then we have a very essential visualization for any data analysis, a heat map. So here we have this heat map gives you the correlation between, like I said, two of the most important features in our schema. So you have one identity label and the other is your toxicity labels. So the identity labels, like I said, gives you uh, the identity of the comment. Say if it's mostly, if the comment is mostly associated to a particular identity of a person, say a race or color or community or something like that, sexual orientation or something like that, religion, and so on. So when you kind of we intend on seeing the correlation between that and the correlation of comments that indicate the directly toxic words. So you can see here that black, the word black, and is mostly correlated with the toxicity label being identity attack, insult, and severe toxicity, targeting someone, and so on. So this, and not only black, you can see even the word Muslim is highly correlated with the same thing: identity attacks, insults, target, and so on. This gives us a picture of how racial discrimination, or how discrimination or insults or civility is affected with respect to the identity of a person, say race and all. So you have a positive correlation for them, like, so that clearly indicates that comments associating black and the comment being categorized as insult and more of an identity attack is higher. The chances of it being is higher. So this gives you a very broad image of how each identity label is toxic, and how they are correlated with these toxicity labels. So this gives us a good view of how to go about with an analysis. So this is basically weighted toxic. So weighted toxic not it not only takes into account your the target, but it also takes into account the population. So as in the population of that particular that particular word in your comment section. So that gives it the weighted toxic. So if I'm you can see that the whites, as in the word the identity label white is most heavily toxic, and then you have black, and then so on. This is basically more of a analysis of the demographics of your data, and not exactly very text specific. However, we thought that we should do this also in comparison, because when we had a good look of how this was done in a lot of previous works, previous papers, and we thought that we had to compare how our process differs from it. So then a very important EDA visualization is time series, to know about how which time period or timeline mostly coincides with this. So we can see that there is we have basically done this with a very specific, with a very specific identity, say race. So we have taken into account only the race labels in your identity labels. You can go ahead for so on, but this is because we noticed that in this correlation graph, we noticed that most of the highly correlated tend to be with respect to race. It was mostly for black, white, and Muslims, and so on. So we thought that we could do this mostly for the race. And when we went about, we could see that the toxicity levels tend to increase. Was mostly was increasing. So it was increasing and tends to be very high in 2017. This could be attributed to a number of events that happened in 2017 and so on, which could have led to this um, rise in toxicity and race, relation between toxicity and race. But that is for us to see. But so basically, when we look into how what exactly we can conclude from this exploratory data analysis, is that we can see that over 30% of the samples which are identified as homosexual, gay, or lesbian, or black, and white are considered to be toxic, which is much higher than the remaining identities. And then most of the toxic comments, like I said, tend to be short, and this could be just one word exclamations or swear words in your comment section, which is not exactly targeting someone. So that could be one of the reasons. And then there is a heavy imbalance between the number of comments, toxic comments, and non-toxic comments. This is what we have to look into. Like I said, there is like 92% of toxic, 92% are supposed to be non-toxic, and only 8% are supposed to be toxic. So we have to get a good look at that, and we have to see uh, about how these exactly how non-toxicity relates with identity. So most of them tend to be short. So
So let's go into the details and the approach which has been taken and outlined in the paper published by these Google engineers to solve this problem. So the main point here is we have to measure how much of the unintended bias is present, then we will be able to reduce that bias. In the next following slide, we'll discuss what are the techniques to measure this unintended bias and how we will be able to mitigate this bias. So there are two key points that needs to be noted here. The first is pinned area under curve. So this is a new term for you guys. It's probably because it is actually invented in this paper itself. And the next term is how do we mitigate the imbalance in the data using the above um, measure for doing the unintended bias. Pinned AUC. Before discussing pinned AUC, we have to discuss AUC itself and the other term, error rate equality difference. Let's talk about the AUC. So as you already know, the AUC is a very superior metric for evaluating the performance of a machine learning classifier. And to be honest, it's a threshold agnostic approach for evaluating the performance of machine learning classifier. The more the area under curve, the more superior the ML classifier is. Error rate equality difference. So before understanding the error rate equality difference, one thing to note here is, let's look at this table. What does this says? What does this signifies is, all these identity terms which you see on the left hand side, uh, and you look at the corresponding columns like toxic and overall, which says there's the amount of identity terms which are present in the toxic comments and the amount of identity terms which are present in the overall comments, the difference. So let's consider the example of word transgender. Now, the 0.04% of the toxic comments have the identity term transgender, while the 0.02% have only are present in the overall data set. The error rate equality difference quantifies the extent of per term variation, that is, the extent of unintended bias, as the sum of the difference between overall false positive rate and the per term values. Error rate equality difference only provides an evaluation of bias in the context of direct binary classification, or after the threshold has been chosen. We need threshold agnostic approach. That is the reason we have chosen pinned AUC for our evaluation of unintended bias. Okay, so what is pinned AUC? So it is nothing but AUC of the identity terms. As you can see here from this data, the AUC for identity term data containing the identity term tall is different from the overall AUC. Now, how we can leverage this pinned AUC for our measurement of unintended bias is following in the next slide. So before moving on to the next slide, there is a one important term called pinned AUC equality difference. It's actually a difference between per term AUC and the overall AUC on the aggregated data of all identity terms. A lower sum represents less variance between the performance on individual terms and therefore less unintended bias. Okay, so there are some experiments that are outlined in the paper to prove the concept of pinned AUC and how it helped in mitigating the unintended bias. So as you can see, there are three models that are used for this experimentation purpose. A baseline model, which had all the comments, the unbalanced data from the Wikipedia talk page or the data set which is provided over the Kaggle, and there is this bias mitigated model. This is a carefully trained model because the data set had been modified in such a way that there is a balance between the toxic and non-toxic comments. Now, how did these people got these 4,600 additional comments? Is basically through unsupervised technique to group the all the comments from the articles itself, which contains the identity text. And there is this third model called control group model. This is just to prove that randomly adding any data to your data set would not help in improving the performance. That is the exact reason balancing the data set is difficult, because you have to know what balance has to be maintained and what data will actually create a good balance. Observe the experimentation results. Now there are two columns here. the general and phrase templates. The general is nothing but a general data set, and the phrase templates are the is the data set which is created manually, in which you have phrases, that is the identity terms, substituted inside the templates of both toxic and non-toxic comments. Observe the improvement in performance of the bias mitigated model, which is not the case with random and baseline model. Let's observe the results of sum of differences for these three models. There is a clear proof here that bias mitigated model performed better, but still there are some of differences, positive, negative, and pinned AUC, which are still present even after mitigating the bias, that is balancing the data. Now, if they are still present, how we are supposed to make it to zero? Well, it is not possible to make it zero because bias is present in the human context. There is a problem of annotating these comments to be toxic and non-toxic based on the perspective of the humans. One human can uh, assume that a comment is toxic, while the other can similarly assume that's a non-toxic. So this is a thing. I mean, the paper has outlined the solution and ways to measure the unintended bias, but still open. But this challenge is still open to public because there is no single model which will generalize well, and there is only a way to generalize well is by scraping a lot of data from the different APIs, Twitter, Facebook, and the other public forums, so that the more data we have, the better we can train our model. One of the popular model for solving this problem is LSTM, the long and short-term memory neural network. These are the recurrent neural networks which are specifically used for sequenced data, the text data. And again, as we discussed, the ways to improve this model is to scrap more and more data to balance the data carefully so that the model performs better and generalizes well. Okay, that's all for today, and we have these email IDs here for you. If you have any question, do let us know, and please comment on the comment box